brief introduction on Professor Saman Bandara. Saman Bandara is a professor in civil engineering, University of Moratuwa. He has received primary and secondary education from Royal College Colombo and graduated from University of Moratuwa as a civil engineer. He obtained PhD in transportation engineering with specialization in airport planning from the University of Calgary, Canada. He has over 30 years of experiences in teaching and research. He was a past chairman of the Chartered Institute of Logistics and Transport, Sri Lanka, and has served as the president of the Engineering Architecture Serving Section and the Environment Committee of the Sri Lanka Association for Advancement of Science and the Vice President of Highway Engineering Society, Sri Lanka. Professor Bandara was the founder director, undergraduate studies, Faculty of Engineering at University of Moratuwa, and the founder head of the Department of Transport and Logistic Management of University Moratuwa, and the founder head of School of Construction and Civil Engineering at North Shore College of Business and Technology. Professor Bandara has served in a number of national level committees in the areas of public transport, traffic planning, airport development, road safety, highway engineering, and environmental assessment. He is a member of the editorial advisory board of the Journal of Advanced Transportation. There are over 150 national and international research publications in the above areas and joint patent for Uniroad traffic signal system to his credit. So, ladies and gentlemen, let's start this session. Sir, let me have the honor of inviting you to the chair this session.
Thank you for kind introduction. So let's start on this session on transport and traffic engineering. So there are 5 papers lined up for the evening presentation, ranging from traffic engineering problems to road safety. So more towards traffic engineering, I would say. I think according to the procedures laid down by the organizers, each presenter will get 15 minutes for the presentation, and after 13 minutes we will give a warning, and you are supposed to finish within 15 minutes. So you have to plan your presentation. And then at the end, we will have a question and answer period of another 15 minutes, where the questions will be directed to individual presenters, and we can have a discussion. There is no hard and fast rule. Only the author can answer, and if time permits, others can give contribution, because the idea of these kind of conferences is to share experience and disseminate the knowledge. Right. So without further delay, let me introduce the first presenter, Dr. R. Wijesiriwardana. The paper presented by Dr. Wijesiriwardana is a traffic flow unconstrained path solutions for evacuating from multiple regions to safer regions using graph theory and dynamic programming, so related to disaster management, and co-authored with Professor D.T.F. De Silva, Professor, Department of IT and Mathematics, John Kothalaula Defence University. Dr. Wijesiriwardana is a lecturer of biomedical engineering at General Sir John Kothalaula Defence University. His research interest includes physiological information monitoring systems. He has produced more than 20 international publications in journals, conferences, and trade shows. He is an inventor and published more than 10 international patents. His Innovative products are marketed by international companies such as Radisson and Adidas. So let me invite Dr. Wijesiriwardana to present.
Thank you, Chairperson, for that kind introduction, and senior professors, distinguished guests, and my dear colleagues and students. My presentation will be on an algorithm, and I have two tasks for the next 10 to 15 minutes. And first one is to deliver the speech within 10 to 15 minutes, and the other one to keep you awake. So I'll try my best. Okay. So for the next 10 to 15 minutes, I'm going to talk about the algorithm I developed. It's unconstrained traffic flow path solution, which I used graph theory and dynamic programming. And this is very helpful in evacuating people from multiple regions to safe regions during a disaster. So let me outline my talk. First, I will introduce the problem, and then I'll discuss about the formulation of the problem, and then I'll go to the algorithm implementation. After that, I'll discuss about the results, and finally end up with the applications. To kick things off, let's discuss about the problem. As we all know, during a disaster, it is very important to guide the people to safer zones from maybe single disaster zone or a multiple disaster zone. So this process usually systematically done by using evacuation path maps. I'm not sure in Sri Lanka, but this has been done in Second World War as well as the First World War as well. Used to do it in the Gulf War as well. And usually these maps are basically graphs, and these graphs are obtained by using either geographical maps or building maps, or inside the cruiser there are maps as well. And you can take any geographical map, and then you can consider the junctions or the zones as nodes, and the roads that connecting or the pathways that connecting these junctions, you can assume it as a link. So when you consider this link, each link is becoming a state variable. So it's a tri-state state variable. So it can be 0, 1 or -1. That means you should avoid the path 0. You should go forward direction, it's a 1. And you should go the backward direction, it's -1. So it's a tri-state variable. When you consider all the links on this map, it constitutes a vector, and this is the solution that we need to find the solution. So there are several approaches. Of course, the most easiest one is to do the manually, but this is very time consuming, as well as you may not gonna get the optimum solution. And most of the disasters happen, and after that, especially around the 9/11 disaster as well, they didn't have a plan, and they used to go to the manual system, and that resulted in a lot of casualties. And the Chernobyl, the same thing happened, and recently when the ferry went down in South Korea, similar situation happened as well. So there are two other more common approaches available. First one is the network flow method, where you use a cost function, and then you can use the linear programming to optimize it and then route accordingly. And Professor Pereira today morning discussed about the complexities of the linear programming as well, and the time consuming of these algorithms. And the other one is the simulation techniques. Either you can use a stochastic processes or Monte Carlo optimization process methods, and these ones are once again very time consuming as well. In addition to that, you need to consider the traffic flows and the traffic speeds, the perception impedance and the paths and the traffic volumes as well. So there are a lot of factors comes in as well. And more importantly, you need to have very high speed computers to deliver the solution as well. And if the condition is dynamically changing, such as if the multiple bomb blast situation, and after one bomb goes off, another one goes off as well, and if the fire is spreading throughout, so it's a dynamic situation. So the solution need to be updated time to time, and that takes a lot of time. So we need a very fast solution. So the fourth method is by using the heuristic approach to this problem.